Welcome, everybody. We are going to meet in this classroom again next time as well. And this is going to, I hope, be kind of a fun thing, being in the computer lab, because you're going to start to get a sense for how much more easily the computer is able to help you solve these problems than when you do them on paper, when you do it sort of the manual brute force approach. And I'm going to help you to learn Excel this semester well enough that you can apply it not only in this class, but you're going to start to see that it's a really valuable tool that you can use in other classes as well. So maybe some of you are already Excel wizards, and that's great. Some of you maybe have never really used Excel very much previously, and that's not anything to be intimidated about. It's not a problem. I'm going to show you from the beginning to jumping right into some really complicated problems how you can be successful using Excel. So I'm excited that we get to do this. The only disadvantage is this classroom feels a little bit too big and spread out, and I can't quite keep an eye on the people on the back row, what they're doing. So anyways, all right, let's look at this. Tuesday we're meeting back in here again, and your assignment number 4 is due on Tuesday as well. If you didn't already pick up your graded homework, then you can get that at the end of class along with the quiz. Just to reiterate what I've mentioned before, if you ever have a question on the quiz grading or on the homework assignment, please feel free to stop by during my office hours, and I'm happy to go over it with you. You know, I don't grade the homework, it's a homework grader, and so it may be that the grader has misunderstood one of my requests, or that maybe the grader's made a mistake, or maybe I've made a mistake, and so please let me make it right. If you think there's a problem, just stop by and we can sit down and go over it together. All right, so today we're going to be talking about interest factors, finding I and finding N. Any questions about the announcements before we get into the new material? All right, well, let's just dive right into the in-class exercise. What we've got is a cash flow that includes a gradient and a uniform series on top of each other. They're both occurring simultaneously. And so in this problem, it says, for the cash flow diagram below, solve for the present value. And my suggestion is break the cash flow diagram into 2 parts, a P/A and a P/G. And so let's look at what that would be. We're trying to find out how much is it worth today, or you know, if you're going to get money now and then you have to pay in the future, how much should you get now in year 0? And so there's 2 components to this. The first component is the uniform series, or sometimes as we call it, the annual series. So every year for 5 years, see how many have we got? 1, 2, 3, 4, 5. What amount should it be on this uniform series? What is A equals how much? 400. So every year there's 400. And then this is what we're going to say, what we want to find here is P. And to do it, we could do find P given A. The second part, if we break it up into pieces, is we're going to find some P. And here's year 1, year 2, year 3, year 4, year 5. All right, so now this is the gradient component. Who remembers how a gradient works? Here, what G is it? 0G, then G, 2G, 3G, 4G. What's the amount of G? G equals 30. And so what that means is that what we should see is in year 0, there's an extra 0. I'm sorry, in year 1, there's an extra amount of 0. And then in year 2, it is 30. Year 3, it should be 60 because it's 2G. And then in year 4, it should be 90. And year 5, 120. And then we can find P by doing a P/G operation. Any questions so far on breaking this cash flow diagram up into 2 segments? If you add these 2 together, then you get that. So we're doing the reverse. We're splitting it because we need to solve it in pieces. Okay, I've been suggesting that we get acquainted with like a way of summarizing problems like this. And it starts in brackets. So brackets P/A, and then I equals 12%, n equals 5. That's how we would summarize this problem. And then we would summarize this one, P slash G, I equals 12%. What about n? Is the n different? Because it looks like we're only having 1, 2, 3, 4 payments. It's still n equals 5, because the gradient series, like the standard form, is to have 0g, g, 2g, 3g, 4g. And so year 0 for the gradient is still here at 0. So the n isn't different. Just because there's only 4 outflows, we still have to say n equals 5. It's just that the first outflow you see in a gradient occurs in year 2. All right. You're going to solve this one using formulas. And I set these on the front chair here. If you didn't get this, come and grab it. So here's the formulas that you'll need for P slash A and for P slash G. And so we know A equals 400. We know that G equals 30. And so find out what is the P of this top one and what is the P of this bottom one, and then add them together for the total P. All right, so I'm going to stop talking, pause the recording, and let you get started on solving this one using the equations. So you're going to have to use the formulas that are provided. There's lots of opportunities to make mistakes on these, right? Because the formulas are very complicated. So I broke it up into 2 parts. Part 1 is the uniform series, the P slash A. Then part 2 is the gradient, the P slash G. So the 400 every year, that's the bulk of it, is the 400 every year. That's where most of the money is. If you take that to the present, it means that you would have to receive 1441.91 in order to make those payments in the future, the 400 recurring. All right. And then part 2 of it is even more complicated, the formula. It looks pretty nasty. You know, you do the wrong exponent, you do the wrong subtraction. I got in the habit when I was in college of triple checking my calculations. And so the first 2 would tell me if I got the same answer twice, then I wouldn't do it a 3rd time. But yeah, so anyways, you get the overall factor is 6.39 for the gradient. Multiply that by the value of the gradient is 30. And so all of the little extra amounts, you know, all this little 30, 60, 90, 120, you take all of that to the present, and it's only worth $191 in present value. And so combining the 2, the 1441 and the 191, then that's where the 1633.82 comes from. All right. Questions about this example? So now you've seen a gradient on top of an annual series. The next level of complication is when we start moving the gradient different years apart. Like if the gradient doesn't actually start in year 0. And so expect that curveball in the future. Any questions before we move on to part 2 of the in-class exercise? All right, so the next question is asking, a contractor purchased equipment for $60,000, which provided an income of $16,000 per year for 10 years. What rate of return did the contractor realize on the investment? So the first part that you're doing on the paper is just draw the cash flow diagram. Should take 1 minute. Once you've got the cash flow diagram drawn, I'm going to unlock the computer so you can follow me as I do something on Excel. All right? So just draw this cash flow diagram. It's an easy one. No, it's going to be more than that. It's going to be like around 23%. Yeah. Mm-hmm. Okay, I think most people have the main idea. Now, my solution that I'm going to pull up on the screen, it's missing a few things. So why don't you tell me what my solution is missing? Let me scroll down. All right. All right, I didn't put P equals for the 60,000, so -1 for me on that. I'm not putting the amount of the A, and I'm not labeling the A, so -2 points for that one. And then, remember, I could have said I equals question mark, just to illustrate that I'm trying to find the unknown interest rate. And then also, it's a good habit to put the years. So 1, 2, 3, 4. So this is really deficient. You guys shouldn't put up with this sort of nonsense out of your instructor. So I'll do better next time. All right, so let's do the computer stuff, all right? I'm going to turn on your computer so that you can follow. What we're trying to do is, what is the interest rate? So let me give you the main idea. You pay $60,000 now, and you take out $16,000 every year for 10 years. How much interest do you have to receive in order to make that possible? So you have to go searching for a bank account that makes what interest rate so that this series of payments, so that you can start receiving these series of payments over time. All right. Does that fix the computers? I've never used this system before, but it seems pretty straightforward. Does everybody have control of the computer now? Bring up Microsoft Excel. It's the green icon. All right. Does everybody have it up? Excel? Okay, so follow me as we, first of all, save your file somewhere, because you're going to want access to this as you do the homework, just as a reference. So you can save it on your network drive, or you can put it on a flash drive if you carry one with you. So you'll notice I've already saved my work. So that's the first thing, is name the file. And don't just name it spreadsheet 1. You know, give it a good name, like in-class exercise 10, something like that. All right, so I'm going to label this ICE 10 problem 2. Now remember, this is being recorded, so if you get lost along the way, don't panic. You can just go back to the YouTube video and watch this. And because of that, I'm not going to feel like I have to go super slowly. I'm going to go at, just an average pace. All right, so now do I equals, and then tab. The tab button will take you to the next cell to the right. Now, it will be okay for you to talk amongst yourselves in a few minutes, but for now I prefer it if I'm the only one talking. Okay, so I equals, and then in the next cell, we don't know what the interest rate is. That's the whole point of this question, is we're trying to solve for it. So just as a starting point, let's say, what if it was 1%? So type in 0.01. And we're going to play around with that interest rate to see what's the answer. All right, now below that I'm going to have year, and then one column that's titled amount, another column that's titled present value of the amount. That's a mouthful. And you can change the width of the column like this. Or another way of doing it is you can just double click in it at the top, and then it'll make it wide enough. If you just go up here to the top and double click. All right, so the last one I'm going to call, for now we're just going to have those 3 columns. All right. So far we're just doing the easy stuff. Any questions about what we've seen? You can do formatting. If you want to make it look pretty, you could center these. Show the ribbon. I don't want that. Oh man, that's even worse. All right, so if I want to center it, I'll go like that. Okay, so year. There's 10 years here, so I'm starting with year 0, 2, 3, 4. Now it can get tedious typing in all of the years like that, and so if you highlight all these cells, and then watch, down here is a green box, then you drag that down, then it'll automatically number them for you, so you don't have to type it in. So that makes it a little bit easier. So again, what I did was I typed in the first few manually, then highlight the ones you've got already, and then drag it down, and it continues the pattern. And the pattern is increase the number by 1. Okay, and I'm going to center it. All right. You have to have 1, 2, you have to have at least 2 numbers, and then it will continue the pattern. Highlight.
Yeah, highlight the whole thing.
Highlight 0 and 1, and then it will know to do the rest. Highlight what you've got. No, yeah, stop at 2. And now, let go. And now, Control Z to undo. All right, highlight 0 through 1. Okay, there you go. That's it. Did it work? All right. Okay, so if you're not yet getting the hang of how to drag down, you can just type it in manually, but you'll get there eventually. Okay, so the amounts. Now this is where we just type in the amount from our cash flow diagram. The first one is negative 60,000 because we were paying, and then all of the rest is we are positive 16,000. And it's boring to type 16,000 so many times, so I'm going to do the same thing where I'm just dragging down and it will repeat the value. All right? Now, the currency here is dollars. And so I'm going to add currency to it. So highlight the whole range. And then over here where it says general, I'm going to bring it to the drop-down box that says currency. Now, there's no right or wrong answer if you like to format it with accounting, currency, or just leave it as numbers. But I prefer to see it listed in the currency that's described in the problem statement. So I'm going to click currency, and then it adds all these extra zeros at the end. If you don't like to see the cents, then you can decrease the decimal, so now it's just showing the dollars. And also, I'm centering it. The main thing is that you have the amounts. Yeah, let me show you. If you just have the amounts like this, highlight it, go to the drop-down box, and now do currency, like that. And then I don't want to see the cents because it's just getting too busy on the page, so then I decrease the decimal to now it's only showing the dollars, and I've centered it. Okay? So what we've got on the screen here is we've translated the cash flow diagram into a table. Here was the cash flow diagram, missing a few important details like we already admitted. So here's the cash flow diagram, and now it's translated into a cash flow table. So this is showing that in year 0 we pay 60,000, and then years 1 through 10 we receive 16,000. So the question is, if you put all this money in the bank, if you put 60,000 in the bank, how much interest do you have to earn so that you can withdraw 16,000 every year until year 10, and then at the last withdrawal, there's nothing left. So that finishes all the money in the account when you take out the last 16,000. Any questions so far? Let's start to do the calculations, and this is the part where it's really important to pay attention. I've got several things, and you may want to write on the paper the main points that I'm going to show you. The formula here is called equals PV. Equals tells Microsoft Excel that you're doing a function, that it's not like text that you're putting in, that it's a formula that it should be on the lookout for calculations. So that's what the equal sign means. So equals PV means you want to find the present value of some amount. What we're going to be doing is we're going to take all of these future amounts and move it to the present. 60,000 is already at the present, but everything else is in the future. This first 16,000 is in year 1, this next 16,000 is in year 2, and so on. So we're going to discount all of those future amounts from the future to the present. So that's what the equals PV function does. So when you put in equals PV and then now a parentheses, it starts to give you some hints on what it needs to see in the formula. Once you put in that parentheses, now it's saying, all right, so it knows it's doing some money calculations. It's asking, what interest rate should I use? Because it wants to know, if you're moving things from the future to the present, what is the interest or the discount rate that it should use? Now, we don't know, right? That's the whole thing we're trying to solve, is what is the interest rate? So what I'm going to do is I'm going to point it towards this cell B3 where the placeholder value is. For now, I'm just using 1% as a guess, and then I'm going to fix that guess until I get the right answer. So what you should do is just click on the cell where this 1% is. If you click, then all of a sudden it enters B3. So click in the location and then push the F4 button on the keyboard. What the F4 button will do is it's going to add dollar signs in front of the B and in front of the 3. That's called anchoring the cell, like a boat anchor. Let me write that on the board here. A-N-C-H-O-R, anchor. And the reason why we need to anchor it is, remember when we've dragged things down? I don't want to type in the formula over and over so many times. Quieter, guys, quieter, please. So I'm going to drag it down so that it applies the formula many times. Anchoring means I always want it to always look at that cell for the interest rate. So if it's not anchored, it would start looking below it as I drag the formula down. That's why I need to anchor. So rate, and now I put in a comma. NPER means N. Do you have a question? Anchor it by pressing the F4, or you can just type in those dollar signs manually with Shift 4. But F4 will automatically anchor it as long as you're still in the part of the formula where it's referring to B3. Okay, so again, PV, put the parentheses, click on the location where the rate is, and then push F4 to actually activate the anchoring. And now the comma, now look what's bold. Now what's bold isn't rate, but now what's bold is NPER. That means N. What year is it? And so here I'm just going to say it's year 0. I'm going to click in the location that tells it what year we're currently in for this row. This row is year 0. The next row, since I'm not going to anchor this one, I'm going to drag the formula down, and so next time it's going to look here at A7, and it'll see the number 1. And then when I drag it down further, it's going to see this value of 2, and so on. So this one we don't anchor. Any questions so far? All right. So now we put in another comma, and what's bolded here is PMT. Any guess on what the abbreviation PMT means? It doesn't mean present, it means payment. It stands for payment. Now, this 60,000 isn't a payment, it's a one-time amount. And so we just need to skip over this payment field. And even the 16,000, we're treating that like a one-time amount because it's, we've got every individual payment on a different row. And so the individual rows are referring to individual years. And so I'm just going to put in another comma, and that skips over the payment. And now you'll see what it says is FV. What does FV stand for? Future value, right. And so what I'm going to tell it is, here is the future value. Now 60,000 is already in the present, but it's at year 0. So it's not going to change the amount of the 60,000. So I just click here in the amount. But there's a catch. And this is sort of a silly thing that Excel automatically does. It changes the sign of the amount anytime you do a PV calculation. And so what we need to do is go in there and manually put in a negative sign before that. So this ends up being the function that when I press enter, it's going to tell me what's the present value of $60,000 in year 0. It should be $60,000 because we're moving it from year 0 to year 0. So enter, and it tells me 60,000. Now it's red because it's formatted right now in accounting style. So I'm going to click currency, currency, and it changes it back to the way that I like. Red just means negative amount. Do I need to do it again just to show? From the beginning, all right? Here's the formula. Equals PV, the rate is here, anchor it by pressing F4, comma, N is the year, comma, and I'm going to skip over the payment field with just another comma, so I call this double comma. Okay, skipped over the payment field. The future amount is negative of this, and then parentheses. All right, enter. And you may need to change it from, if you want to get rid of the red, just force it back into currency mode, and then you can eliminate the cents if you don't want to see them. The beautiful thing about Excel is now that we've typed that formula in one time, we don't have to type it again. We can just drag down using this little grab spot here, that little green box in the corner, the lower right. If we drag it down, it's going to automatically apply that formula to all the rest of the rows. So here I'm dragging it down, and then I let go, and look what it did. Now the question is, you should always ask yourself this, does it make any sense? Do the numbers it's giving you make logical sense? And so it's saying, for example, $16,000 in year 10 is only worth $14,485 at the present, if the discount rate is 1%. So does it make logical sense that this amount is smaller than the amount from year 5? Who can explain, just in your own words, why is it that you should see the amount constantly getting smaller and smaller? Okay, inflation. What we're doing is, here in year 10, the money is moving a greater number of years. So money in 10 years isn't worth as much as money in 5 years. And that's what this column is saying is, how much is it worth now? $16,000 in year 10 is worth $14,485 now if you are discounting at 1%. Okay, so does everyone feel like they understand the interpretation of the table so far? Any questions? Remember, I like questions. Do you have a question? You're just stretching? All right. Yes? Ah, okay. It's because, did you put the negative here in the formula? All right. Was this amount negative? Let's see. Oh, this is negative. It's just that it's red. So the red means negative. So you need to change the formatting. If you're just seeing this, that means negative. The brackets like that, so change it from accounting, change it to currency, and then you'll see the negative sign. All right. Okay, so now we need to find out what interest rate is going to make this all balance. Here's the key to the whole problem, so you need to listen to this part very carefully. We're solving for the interest rate that makes the outflow and the inflow equal each other. So we have a payment in year 0 and then revenue in years 1 through 10. What interest rate makes everything balance out? Let's find out if it's in balance right now by adding together the present value of the amount. So what I'm going to do here is I'm going to sum everything. And so the formula for adding stuff up is equals sum, parentheses, and then you just highlight everything that you want it to add together. And close parentheses and enter. If it's in balance, the sum should be equal to 0. Equals sum. Okay, so let me do it again. Equals SUM, parentheses, and then highlight everything. 91,541. So it's not in balance yet. what we want to do is we want to find out what interest rate is going to make this sum equal to 0. So let me change this interest rate and see if it makes it closer to what we're looking for or worse. So let me write a little note here. We are looking for the interest rate that will make the sum of the present values equal to 0. Inflow equals outflow. That's our objective. You don't have to write all that. If you need it, it's on the video. But what we're going to do is play with I. So what about 2%? Is 2% taking us closer to a sum of 0? 0.02. Yes? Okay, so then what should we do? We should maybe try 3%. Even better, right? Okay, well that can get tedious if we keep doing, what about 4? What about 5? You know, so let's jump to 20%, 0.2. We're getting awfully close now. What about 25%, 0.25? What does that mean, negative? We went too far. So the answer is somewhere between 20 and 25%. What it means is if it's 25% rate, then it's not in balance. And so I'm going to show you a really powerful tool right now that's called Goal Seek. What it does is it automates that iteration process. Doing something over and over and over again, that's called iteration. So we were at 20%, right? And 21. All right, so follow this. You go into Data tab. Now there's something called What If analysis. So on the Data tab, find the What If analysis. Click on that, and we want Goal Seek. So here is the Goal Seek. Does anybody remember what our objective is? We want the sum to be equal to 0. So it's saying the goal is set cell, so I need to tell it what cell to look at. Set this cell, which is the sum, and our goal is the value of 0. Now in this third thing, it's asking what can it play around with to make that goal happen. And so it can play around with the number where I've got the interest rate. Okay, so set this to 0 by changing that is what this Goal Seek is what I'm telling it. Yes. Yes, I can. All right, so let me tell you from the beginning. Okay, you're starting at home. Can I have it quiet, please, guys? Okay, so data, what if analysis, goal seek. We want this to be equal to 0 by changing the interest rate. And then once you click OK, some numbers are going to change around for about half a second, and then you're going to see the answer down there, 0. Okay. Okay. So the answer is 23.4%. That's our interest rate. That's the interest rate that makes the present value of the 60,000 equal to the future value of all those 16,000s. So that's the interest rate. And there's an even easier way to solve this problem. Most of the time I'll ask you to solve it this way, just because knowing how to do it this way is going to make bigger things possible in the future. Like you can solve more complicated problems if this sort of a solution makes sense to you, and if you could set it up on your own and solve it and it feels logical, then that's going to be very valuable. But there's an even easier way, so let me show you the even easier way that only kind of works for this problem itself. Okay, so there's a function called rate, equals rate, R-A-T-E, and then the way that one works is you just tell it N is NPER, means N, so there's 10 years. The recurring payment is 16,000. The present value is negative 60,000. Close parentheses, enter 23%. And it even knows all of the decimals that we got from the other part. 23.41%. So that's the rate function. Any questions about that? All right. So I'd like for us to take a stab at this third problem. You're going to do something on paper, and then I'm going to demonstrate something on Excel. Okay, so for the third problem, a contractor is purchasing equipment for $60,000 that provides an income of $8,000 per year. And it just keeps going and going. This $8,000 is for a lot of years. Interest rate is 10%, so how many years until the investment breaks even? So, first of all, on this problem, what is P and what is A? What amounts? What is P? 60,000 is P, A is 8,000. So what is the ratio A divided by P? Anybody have a calculator can tell me what is A divided by P? 0.1333. Okay, so that's the ratio of P to A. A to P? Yeah, that's the ratio of A to P. Okay, so now let's go down here to the table and find the A/P column. Here it is, A/P. And then this is the 10% table because we are working with an interest rate of 10%. Where do we have it go to that A to P? How many years? Which is it? Is it 14 or is it 15? It's between them. So what that means, let me show you the illustration of what that means. Roughly speaking, you can say the answer to the question, the number of years until the investment is profitable. In the 15th year, the investment will be profitable. In the 14th year, it's almost profitable. You've almost got enough money back to pay off the original investment. But then by the 15th year, the investment is paid off, and now all the additional money is just profit. So let me show you how we would do that using Excel. Don't try to follow along on this one. You're going to have a chance to do this next type in the future. But what you would do for in-class exercise 10, problem 3, okay, we've got some interest rate. In this case, it's not unknown. We know it's 10% interest rate. And I'm going to have a year, an amount, a PV of amount, and then I'm going to have something called cumulative PV of amount. It's much better just to watch on this one. Don't try to follow along. Okay, so the years are going to be 0, 1, 2, and it continues for a while. Okay, now the amounts is that paying $60,000 to buy this item and then receiving an income of $8,000 for an unspecified number of years. All right. I'm going to change all of this to my preferred formatting of currency without seeing the cents, and I'll center it. All right. So PV of amount, you've seen that function already, equals PV. Here is the rate, anchoring it by pressing F4, comma, N is whatever row we're on. So here is the 0 year. So I'm going to just click on the location. I'm skipping over the payment because this isn't a payment, it's a one-time amount. I'll have the negative of the amount that's shown. Okay, so 60,000 in year 0 is worth 60,000. If I drag it down, what we should see is that 8,000 in year 17 isn't worth very much in today's terms. And that makes logical sense to us. We're discounting at 10%. That's a pretty high discount rate. So it means all the future money is worth very little in today's terms. So here's the last part. This is sort of the tricky spot. Cumulative present value. So in year 0, all we've done is we've paid 60,000. So the cumulative amount is negative 60,000. Now in year 1, we've paid 60,000 and then we got 7,293. Now that's the amount, that's the worth of 8,000 in the viewpoint of year 0. So what I do is I have the previous year, So equals tells it, let's do a formula. So equals, and I click on the previous year, plus this amount, the 7,273, and then enter. And what that does is it tells me how much of the 60,000 that I invested is still outstanding. Now, how much haven't I got back? Because at the end of year one, finally I got some money back. I didn't get 8,000 back because 8,000 isn't worth as much in the present as it is in year one. So this column is telling me from the viewpoint of the original 60,000, how much of that original 60,000 is still either outstanding, meaning you haven't got it back yet, or how much of it have you got back. So now I can drag that down. And what do you notice about when it crosses from negative to positive? It's the same thing as that ratio. If we go back to the table, it was between the 14th and the 15th year that ratio equaled what we calculated, 0.1333. So the ratio in the table told us it was between the 14th and 15th year, and here this is saying that in the 14th year you still haven't got all your money back, but by the 15th year when you get this payment, finally now you've broken even on your original investment, and all the additional money from here on out is just extra profit. All right. I hope you enjoyed working on the computers today. Save your file. We're going to be back in the same classroom on Tuesday. Well, we're out of time. I'll repeat it, but I want to release the rest of your classmates from being here in this room. I don't want to ever hold you late, so class is over, and then I'll go ahead and repeat this last part for anybody who wants to stick around. Otherwise, of course, it's on the video, so you can just watch it that way. Okay, so you want me to repeat everything? Okay, sure, I'll do that. What you do is you equals, and for the first one it's just this column, and so enter, and then for all the rest it's the one above it, so this one plus the one to the left of it here, like that. And then once you have it, you can drag it down, like so. All right, see you next time. 1 second.